Hey everybody, we're going to look at weak acids and weak bases. Acetic acid, it's a weak acid, and we're going to look at another particular compound called sodium acetate. All right, you should notice something, or you might be noticing the acetate and acetic acid. All right, and the way this video is going to work is we're going to do a little bit in the lab, do a little bit on paper, and then go back to some of the images in the lab. All right, now what I want to start by doing is just measuring things pH. This is a solution of acetic acid. I've got some in this beaker. All right. Now, there you can kind of see it. All right. That's hitting on the orange side of things. And if I measure the acetic acid's pH, you can see the number there. There you see it's going down. It's definitely acidic. All right. Now, the curious thing is when I go to measure, I'm cleaning off the pH meter. When I go to measure the acetate, the sodium acetate, all right, there I do you can see that this is turning a light blue and that's turning a green. So sodium acetate is, you can see it looks that like there, the green, right? Here's sodium acetate. You can see the pH meter there below. There's the pH meter there. And then here is the pH paper. So this is turning green and that's turning blue. That means that sodium acetate is a base and acetic acid is an acid. All right? Now, let's look at these things a little bit closer. This is acetic acid, and you're not going to be asked to memorize it. All right? In water, it's a weak acid. It forms H3O plus and acetate ion. So hydronium and acetate. Now, this is an acidic solution. If I have this, in solution, its pH was like 3. All right? Now, when I had the sodium acetate, and acetate, in this case, we're going to leave, the compound is sodium acetate. We're going to leave sodium out because it's a spectator ion. What happens here, we found out, this is sodium acetate. Its pH was around 8. So this was a base and this was an acid. So this takes a proton to form this, and OH negative. So these two things are linked. This is my acid, and this is known as my conjugate base. All right? Here now, in this time, water is acting as a base, and its conjugate acid is hydronium. All right? And then down here, here's my base. This is my acid, and this becomes this. This is my conjugate acid. And here is my conjugate base. All right? So, weak acid plus water is going to form, since it's a weak acid and it doesn't protonate, it's going to form a conjugate base and a conjugate acid, all right, and a weak base and water form conjugate acid and conjugate base. All right?
Sometimes your kids hit the ice. Sometimes the ice hit.
Now remember, this is for weak acids and weak bases, not for strong acids and strong bases. So this is something like acetic acid. Let's look at another one. Hydrogen fluoride, HF. Okay? Remember, an acid is a proton donor and a base is a proton acceptor. All right? So what can this do? Well, it can dissociate into H3O plus and F negative. All right? That makes this, since it's changing from that, an acid, and this, its conjugate base. And in this case, it's acting as a base, and this is its conjugate acid. Okay, now, if I look at this one, what's going to happen? Water can act as an acid or a base. What's this chemical going to do? If you knew the structure of the compound, it'd be easier. And you knew that if you knew the structure, then it's easier to see. This nitrogen is very rich in electron density. So electron-rich molecules will tend to accept a proton. If it's accepting a proton, it's acting as a base, making this an acid. All right? And that's exactly what happens. That makes this its conjugate acid, and OH the base, conjugate base. All right? Now, the conjugate acid base pair is two substances related by a proton transfer. All right? Conjugate acid is any base to which a proton has been added. A conjugate base, and its conjugate is Cu conjugate, is any acid to which or from which a proton has been removed. One last thing in terms of trends. A weak acid has a conjugate base. A weaker acid has a stronger conjugate base. All right, and vice versa. The stronger the base, the weaker its conjugate acid. The weaker the base, the stronger its conjugate acid. All right? So, the reason sodium acetate is a base is because the acetate acts as a base when it's in solution, while its conjugate acid, acetic acid, can donate protons, making it an acid, whereas acetate can accept protons, making it a base.